Hi friends, this is Sarvajan here. Welcome to my networking channel. Hope all are doing good. And today the topic I'm going to discuss about QoS Queuing. So what is QoS? QoS is a quality of services which is designed to increase the bandwidth and to reduce the delay, jitter and the loss in the traffic. So that is the purpose of quality of service. And what is queuing? So queuing is used to store traffic before it can be processed or serialized. So that is the purpose of queue. So what is a buffer? Buffer is nothing but the memory allocated, and queue is an algorithm used for determining how the packet stored in the buffer will be sent. So that is the purpose of queuing. So there are two types of queue. One is an ingress and an egress queue. So the ingress queue applied on an inbound of an interface. So it is used to store packet until the router or the switch forward the packet to an egress queue. So the traffic is always placed in the egress queue before it can be serialized on the wire. So that is the purpose of ingress and an egress queue. So let us understand what is congestion. So when the congestion can happen. So assume there is a link capacity when the speed of the ingress interface is more than the egress interface, the congestion can occur. And the second thing, assume the link capacity is, so this is going to some router or some WAN link. So this link capacity, say it is around 64 kbps, and if it is receiving data more than 64 kbps, automatically it will lead to congestion and a packet drop. So that is another thing. And third thing is, if the switch or router is not sufficient enough to handle the size of the forwarding table. So these are the three possible ways when a congestion can happen. So there is another mechanism or what we called as a tail drop. So assume there is an egress queue over here, and a queue can store packets, and assume it is storing packets up to 64 kbps or something like that. So when it receives packet more than its capacity, queue capacity, automatically the newly arriving packets will be dropped. So that is a scenario we call it as a tail drop. So that is one of the congestion avoidance algorithm. So it's a queue management algorithm used to decide when to drop the packets. That's the purpose of tail drop. So that's the reason I told, when the queue is full, the queue can only store a certain amount of packets. So once it receives more than that, automatically once it exceeds the queue capacity, the newly arriving packets will be dropped. So that what we called as a tail drop. And also QoS provides a mechanism to service the high priority traffic than the low priority traffic. So assume in a particular QoS there are three traffic. One is a voice, video, and some ICMP traffic. So if we want to prioritize the traffic, voice and video, I can set it with a higher DSCP marking. Say there are two types of marking, DSCP or precedence marking. So assume voice and video, I'm setting the higher priority marking or a high DSCP marking. So automatically that traffic will be prioritized first than the low priority traffic. So that is the mechanism. Always QoS provides a mechanism to queue and service the higher priority traffic than the lower priority traffic. So what is RED? RED is a random early detection which is used to control the average queue size by indicating to the end host when they should temporarily slow down. So this is, let us take the TCP. So TCP is a transport control protocol which works at the transport layer where data is transmitted in the form of segment. So assume in the TCP there is a sender and the receiver, and sender will send the segment and the receiver will acknowledge it and send it across. So assume the sender is not able to receive any segment. So whenever the sender send a segment to receiver, the receiver will set the window size. So the receiver will set the window size to 1 and it will send to the sender. That means the sender can send one segment. So again the receiver will increase the window size to 2. Again the sender will send 2 segments and will receive the acknowledgement. So again it will say window size will be increased to 3. So until what happens, if the sender is not able to receive any acknowledgement from the receiver, automatically sender can decide there is a congestion at the receiver end. So automatically the sender will decrease the transmission rate. So that is one of the mechanism. The sender can detect the congestion at a earlier state, what we call it as a random early detection. So how it is detecting this congestion is earlier by the means of three mechanisms. One is no drop. So the no drop is used when there is no congestion. Random drop, it will randomly drop the packets. When the queue is full, automatically it will randomly drop the packets. And tail drop, I already told, it is a default behavior. So when the queue is full, the queue can hold only a certain capacity. So when it exceeds that capacity, automatically the newly arriving packets will be dropped. So that is the purpose of tail drop. So this is a default behavior. So there is another congestion avoidance algorithm, what we call it as a weighted random early detection. So this also can detect the congestion at a earlier stage. So by discarding the low priority traffic than the high priority traffic. So assume there is I am defining the classes. Say there are voice traffic and a video traffic and some other traffic. So always the high priority traffic will be placed first, and the other traffic will be placed second or third. So based on the priority, what happen? It will discard the low priority traffic. So if it is some other traffic which is considered low priority, it will discard the low priority traffic. So that is the purpose of weighted random early detection. So let us understand the queue types. I already told there are two types queue. One is an ingress and an egress queue. So ingress placed on the inbound and egress placed on the outbound, right? So ingress is used to store traffic until it can forward the traffic to the egress interface. And egress is nothing but it is used to store traffic before it can be serialized on the wire. So that's the purpose of ingress and the egress queue. So like this, into each interface has a hardware queue and a software queue. So what is a hardware queue? So the hardware queue is it always process the queue in a first in first out model. So it always process the queue in order they receive. Always the first will be prioritized first. So this hardware queue does not require any configuration. So that is the purpose of hardware queue. And there are several type of software queues that I'm going to discuss now. Before that, there are also standard and the strict priority queue. So standard queue is nothing but it is a normal queue where the traffic is treated in a normal way. So there is no priority in the standard queue. But in case of strict priority queue, it is always dedicated for the higher priority traffic. So standard queue will be noted by Q, and the strict priority queue traffic will call it as P. So strict priority queue is nothing but it is dedicated for a higher priority traffic. Say as there is an application like voice and video, always that voice and video will be placed in the strict priority queue. So there is a specific queuing method what we call as a low latency queuing. So in that queuing I can assign that strict priority queue. So if I want to assign that voice and video, I can assign to the strict priority queue. So other queues will be placed in the normal queue. So what is the advantage of strict priority queue? So the traffic placed in the strict priority queue is never dropped due to congestion. And also, if we want to set with a higher DHCP or IP precedence value, it will always placed in the strict priority queue. So that is the purpose of strict priority queue. So this will be always prioritized first, and the packet is not dropped due to the congestion. So that is the benefit of strict priority queue over the standard queue. And let us understand the default form of queue. Already told first in first out. That's the default form of hardware queuing. So does not require any configuration. So it always process the packet in the order they arrive. So let us understand the type of software queuing. One is first in first out and another one is priority queuing, custom queuing, weighted fair queuing, and class based weighted fair queuing and the low latency queuing. So these are the latest methods, CBFQ and low latency queuing I am going to discuss now. So what is a priority queuing is nothing but it is classified as low, medium and high. So always the high priority traffic will be serviced first, then the medium priority, then the low priority. So based on that it will be service priority queuing. So this is the oldest methods, but now we are following this CBFQ and the low latency queuing. So custom queuing, what it will do, it will based on the traffic will be placed in a round robin fashion. So each and every queue there will be separate weightage. So based on the weightage, it will be serviced. And today let us understand about class-based weighted fair queuing and a low latency queuing. So this is already told about priority queuing, high, medium, normal and low. So the traffic assigned to this queue using the access list. So first high queue will be processed, then the medium, then normal traffic, then the low. So this is the way the priority queuing works. So now let us understand the class-based weighted fair queuing. So this works on the MQC. So it supports 64 user-defined queues. So what is MQC is nothing but a modular QoS CLI implementation. So in this thing, I'm using three commands. One is class map, policy map, and service policy. So all this I'm going to implement in a command line, and this is an improved version of command line. That is the reason we call it as a modular QoS CLI implementation. So the class map, first we have to organize the traffic, right? First you have to understand what are the traffic patterns are available. So then first I have to organize the traffic using the class map. So then I will be applying the level of service. So what type of service I'm going to apply to that particular traffic. So that is done using the policy map. So in the class-based weighted fair queuing, each and every queue I can assign a certain guaranteed bandwidth rate. So if we want to set a fixed bandwidth for each and every queue, I can set it using this policy map. So say there is a voice, video and also some other traffic. If I want to set the percentage, so 40% should go to voice and another 30% should go to video and the remaining should be go to other traffic. So that ways I can prioritize using the policy map. And once that is done, I can assign it to an interface. So here only the disadvantage is this queue is not good for voice and video traffic, because this the always you already know high priority traffic, high critical application like voice and video, there should not be any latency and drop because it will have an impact on the voice quality. So always this queue is not preferred for the voice and video. That is the disadvantage of class based weighted fair queuing. So that is done by low latency queuing. So already told low latency queuing is an improved version of class-based weighted fair queuing. So in this LLQ, I can include the strict priority queues. I already told there are two types of queue, standard and the strict priority queue. So the standard will be always treated normally, and the voice and video I can place it in a strict priority queue. So there is a specific command called priority percent. So once I assign that command to the policy map, automatically that specific type of traffic will be placed in the strict priority queue. It is mainly used to stop the latency issues for the real-time application like voice and video. So that is the benefit of low latency queuing. So right, so that is an improved version of class-based weighted fair queuing. So I already told strict priority queues are always serviced before the standard queue. So there can be several queues. Whatever thing I'm assigning to the strict priority, that will be prioritized first, then the standard queue. So that is the benefit of that is the advantage of low latency queuing over the class-based weighted fair queuing, right? So these are the key points you have to understand about queuing. So queue is used to store traffic before it can be processed. And ingress queue is nothing but applied on the inbound. So it is used to store traffic until it can be sent to an egress one. And the traffic placed in the egress queue before it can be serialized on the wire. And buffer and queue I already told. Buffer is a memory allocator. So queue is an algorithm used for determining how the packet stored in the buffer can be sent, and also about the standard and the strict priority queue. So the standard, the traffic is treated in a normal way. So strict priority queue is always prioritized. And also I can assign the higher DSCP marking for strict priority. So if I want to service the strict priority than the normal queue, I can do it. And the method of doing that is low latency queuing. So this low latency queuing is always preferred for voice and video application. So these are the key points you have to understand about queuing and the algorithm. So the congestion avoidance algorithm is tail drop. The default the algorithm is tail drop. So whenever the queue is full, any newly arriving packets will be dropped. So that is one of the thing. And another one latest method is weighted random early detection. So this will drop the low priority traffic than the higher priority traffic. So by doing that, we can avoid the congestion at a earlier stage, right? So I hope you enjoyed this video. Thanks for watching. Please subscribe for more videos. Thanks and have a wonderful day. Thank you.